You might be asking yourself, what is the mean value theorem? I'm glad you asked. Mean meaning average, and it deals with the average rate of change. Let me give you a quick graphical representation of what the mean value theorem really is. Basically, if I have a function, that function exists on an interval. It is important that that function exists on every point of that interval. So I'm just going to make up some function. We're going to graph that right there. And we're going to let the interval go from 0 to this guy right here, whatever it is. So it's going to go to there. So on this interval, there is going to be an average rate of change from here to here. That rate of change is represented by a slope. The first thing you're going to need to do with a problem like this is find the slope on that interval. I don't know if I can draw a straight line here, but I'm going to try. Nope, I was way off. Let's try it again. My goodness. Be a bad day to go target practice. That's not a straight line. Okay, basically though, what I'm trying to get at is I can't draw, and there's a straight line with a slope. The mean value theorem says this. Whatever the slope is on that interval from one endpoint to the other, somewhere on that interval, there is at least one point with an equivalent slope. And you can think about it in terms of tangent lines. I'm going to use my pens as tangent lines. There's a line here, and there is a parallel line somewhere that's going to touch that one. My guess is it's about right here, and so we have this tangent line that goes right there. The point of this is to find that coordinate right there where the slope of the function is equal to the slope on the interval, the average rate of change. Okay, so let's do that problem. Here's the function, x squared plus 7x plus 6, and it's on the interval from -6 to -1. Now, I hope your Algebra 2 skills are kicking in a little bit right now, and you're looking at that and saying to yourself, wait a minute, those are the zeros. Yes, they are. They are. There is a special case for the mean value theorem, and I'm going to ramble just a little bit more right here. This special case is called Rolle's theorem. He's probably some guy that had a foreign accent. It was probably Roulet, but anyway, Rolle. If you have two zeros and you got some function going on in between it, then basically it says that somewhere in between these two zeros there is a slope of 0. Kind of makes sense. It's exactly what I just said, only it's a special case. And this one actually is going to be one of those special cases, but let's go with it just for the sake of making sure we know how to do it. We're going to find the slope between those 2 points, -1 minus -6. Okay, there's a lot of sign changes that we can do. Well, there's that sign change. There's a lot of kind of stuff. But let me just point out what I think you should notice. This is just a wonderful glorified version of y2 minus y1 over x2 minus x1. That should look very familiar to you. Okay, so we're going to plug in a -1 there. We're going to plug in a -1. I'm making sure. Yeah, we get 0. When we plug in a -6, we get 0. 0 minus 0 over something that's completely irrelevant. That kind of looks like the face of an owl on steroids. It's been out all night. Of course, that's what owls do. Anyway, 0. It's equal to 0. This is the average rate of change on the interval. Average rate of change on the interval from -6 to -1. By the way, if you're looking at a calculus book, which is fun to do, I recommend it, they will say a closed interval, meaning that it's the brackets. It does include -6, it does include -1. And let me reiterate one more point. It has to be continuous on that interval. Has to be. If there was a discontinuity of this function, on this function, between those 2 points, this whole thing would fall through and it wouldn't work. And we would just refuse to do it and spit on our paper and write terrible words. Okay, we're going to take the derivative of that because somewhere on this function, the derivative is equal to that average rate of change. This was a very simplified version of it. When you solve this, you get -3.5. And that, my friends, is the final answer.